Okay, for what we have in item number 1, okay, we have two functions, y is equal to x to the 4th and y is equal to x to the 7th. And we're looking at setting up and evaluating the integral that gives the volume of the solid form by revolving the region about the x-axis. Okay, so for what we have here, okay, we have graphed that y is equal to x to the 4th, and beneath we have y is equal to x to the 7th. And we have going from the origin all the way up to our point of intersection between these two functions at 1, 1. And so we have with the interaction that is going on between these functions, okay, between x is equal to 0 and x is equal to 1, or between the points of intersection, y equals x to the 4th is going to lie above y is equal to x to the 7th. And for what we have within the two-dimensional region, okay, we're going to have with the integration about the x-axis, okay, it's going to follow that for the solid you're going to have the formation of the volume determined by the use of the method of washers. Okay, and so we have with y is equal to x to the 4th, since that is the top, okay, this is going to be again the outside radius section. And as for what we have on the inside, okay, that is going to be derived from the open space that we have between the x-axis and y is equal to x to the 7th. Okay, so the closest that this figure is going to be to the x-axis is going to be at y is equal to x to the 7th, and for that particular part, okay, that is going to be once again the inside radius. And now in terms of what we have for the solid that is going to be formed, okay, we have in this particular setup, okay, is going to follow that for this particular item. Okay, we have again forming a washer out of this. Okay, we had the solid generated. Okay, it's going to be something that looks like a bit of a hollowed out bugle. Think of like I have an exterior bugle, and then you have like I guess you can say an internal bugle mold that is going to be extracted from the original solid. Okay, and thus we have the formation of the use of the method of washers. Okay, and so we have with the washer in this three-dimensional drawing, again we have the hollowed out portion represented by r is equal to x to the 7th, that is again the interior radius, and then we have for the outer layer, okay, we have the outside radius again, which is going to be at x to the 4th. And now for what we have in terms of integration in this particular part, okay, again we are looking at in this particular setup, okay, we now have that the volume generated about the x-axis, okay, you're looking at pi times the outside radius squared minus pi times the inside radius also squared dx. And so for what we have in squaring out, okay, and again we're going from x is equal to 0 to x is equal to 1, and so for what we have in squaring out both x to the 4th and x to the 7th, multiplying both results by pi, we have v of x is equal to pi times x to the 8th minus pi times x to the 14th dx, as x goes from 0 to 1. And now readily applying the power rule of integration, okay, it's going to follow that v of x is equal to pi times x to the 9th minus pi times x to the 15th all over 15, as x goes from 0 to 1. And for taking the difference between these two values, okay, the final result in its exact form is going to be at 2/45 pi.